Hello and welcome to yet another video of Cornerstones of Math. In this video, we are going to take a look at some flowcharts. Now some of you may wonder, what? Are you trying to become some sort of computer science channel or algorithm channel or programming channel? Well, certainly not. This is still a math problem, and I will use basic underlying principles of math to solve this problem. But the thing I have realized is that the current educational environment is very different from the times when I was studying mathematics. The most notable one is that there is much greater emphasis on programming and computer science nowadays, giving students more opportunities to learn how to code some basic programs during their pre-college courses. In that regard, it wouldn't hurt to take a look at one algorithm problem given in the form of flowcharts. The problem says, find the value of the variable s printed from each of the following flowcharts. And we are given 4 flowcharts. They look quite similar to each other in the grand scheme of things, but they are also slightly different from each other if you take a closer look. So let us start with the first one. In the flowchart, every process symbol is pretty straightforward and easy to understand, so let me explain only one notation that can be a bit unfamiliar to some of you, the assignment operator, indicated by leftwards arrow, used to assign or substitute values into variables. Here, A left arrow B means substitute the value B into variable A, or change the value of variable A to B. For example, in this flowchart, during the first process, we assign value 3 to x and 2 to y. In the next process, it says we assign the value x plus 1 to variable x, so x becomes 3 plus 1, which is 4, and y is still 2. The next process says we assign the value y plus x to variable y. Since x is 4, y becomes 2 plus 4, which is 6. With this understanding, let's take a look at the flowchart A. We have 2 variables, s and I, and it is useful if we construct a table to keep track of values of these 2 variables. So in the first step, we assign 0 to s and 1 to I. In the next step, s becomes s plus 2i. Since I is currently 1, s becomes 0 plus 2 times I, which is 2. In the next step, we have decision point. It checks whether the value of I is 50 or not. It is obviously not at this point, so we go to here. Here we increase the value of I by 1, so I becomes 2. So we're back to here. So we have to add 2i to the current value of s. And since now the value of I is 2, we have to add 2 times 2, which is 4. And now the process seems quite obvious. I is still far from 50, so we go back to here. I is increased to 3. Then in here, now we have to add 2 times 3, which is 6. So s becomes 2 plus 4 plus 6. And we keep going on and on until I becomes 50. Only then we can escape this loop. So what would be the last term that is added to s? It is evident that s is given as 2 plus 4 plus 6 plus 8 plus so on. And since we can escape the loop and finish the program only if I becomes 50, the final value of I doing this iteration step must be 50. So we do this add 2i to s one last time when I is 50, meaning that the last term added to s must be 2 times 50 or 100. So this is the value of s that will be printed. And it is the sum of arithmetic progression. Using the formula for the sum of arithmetic progression, we obtain the number of term is 50, and the first term is 2, and the last term is 100, so this divided by 2, which gives 2550. Here the variable I simply indicates how many times do we iterate this loop, so it is often called the loop counter. Now let's move on to the next problem. In Flowchart B, the process starts very much in the same way. S and I are given initial values 0 and 1 respectively, and S is changed to S plus 2i, which means S becomes 2. However, the difference occurs from here, because in this flowchart, the value of the loop counter I is increased by 1 before reaching the checkpoint that checks whether I is 50 or not. So I is increased to 2, and then we go back to this process. Then S becomes 2 plus 2i, so 2 times 2, which is 4. Then I is increased to 3, then go back to here, so S becomes 2 plus 4 plus 6, and so on. Now consider the case where I is 49. Then by this process, 2 times 49 is added to S, so S becomes 2 plus 4 plus 6, plus so on, plus 98. Then I is increased to 50, so by this decision process, we simply escape the loop. Therefore, in this case, the value of S printed is this value, so we use the formula for the sum of arithmetic progression again. But now we have only 49 terms, and the last term is not 100, but 98. So this divided by 2, so we have 2450. As you can see, the sum is exactly 100 less than the previous sum, since we didn't add 100 this time. Now the flowchart C. This one looks quite similar to the last one, and the only difference is this part. Now the loop counter I is being increased before adding 2i to S. To be fair, I don't know if there are programming languages that provide this type of loop, but even if there aren't, this stuff can still happen due to mistakes when you code the program. So let's see how that affects the final value of S. We start the same. S is 0 and I is 1. And then I is increased to 2 right away. Then 2i is added to S, so the added value is 2 times 2, which is 4. Therefore, S starts with 4 this time, and the very last term added to S is when I is 50. So the last term added is 2 times 50, which is 100. Therefore, we have 49 terms, and the first term is 4 and the last term is 100. So we obtain 2548. Compared to the answer from Flowchart A, which was 2550, this answer is less by 2, because now the first term 2 is missing. And lastly, the Flowchart D. The biggest difference that you can immediately notice is this part right here. Now the conditional operation is placed before adding 2i to S and increasing the loop counter. Tracking the values of S and I is really simple because we have already done it multiple times. Starting from S equals 0 and I equals 1, we go to here, then S becomes 2, and then I becomes 2, then we are back to here, so S becomes 2 plus 4, and I becomes 3, and so on, until we have I equals 49 here. Then, by this process, 2 times 49, so 98 is added to S, then I becomes 50, and escape the loop. So we have total 49 terms, and the first term is 2, and the last term is 98, so we have 2450. To summarize, these are the values of S printed from each flowchart. For an algorithm that contains a loop to perform some iterative process, the end result can be affected by multiple factors. First, the initialization step. That is, what kind of initial values you assign to variables. Also, the order of these multiple processes, which are adding up certain values to the variable of interest, increasing the loop counter, and checking whether the escape condition of the loop is met. Therefore, if you want to come up with a program that performs the exact task that you want and provides the correct answer, You should be well aware of what kind of iterative processes or loops that the programming language you use provides, and you should have a solid understanding of the flow of your algorithm, so you can design one that can perform correct calculations. And that was all for today's video. Thank you for watching, and I will see you in another video.